Here's problem 3. Again, I recognize this as a law of cosines. The reason being is if it's law of sines, which we learn later on, you always will have two angles given. You'll have a given angle and find a missing angle, or two given angles. And right away I can see that I'm dealing with finding an angle, but I have all three sides. That's an indication that it's law of cosines. And again, the law of cosines, this piece across from the angle, the piece across from it is considered the C piece. These are your A and B pieces. Sort of like the piece across from it, sort of like in a Pythagorean theorem, the side across from the 90-degree angle is the hypotenuse. Well, the piece across from the angle here that we're trying to find is considered the C piece. And again, the law of cosine states that C squared is equal to A squared plus B squared, just like the Pythagorean theorem, except for we got to take away a little bit. We take away 2 times the A piece times the B piece times the cosine of the angle. And that's who we're trying to find here. We're trying to find theta. So we got to figure that out. Well, let's plug in our numbers. C is 21, so it's 21 squared. A I labeled as 34. B is 18. Minus 2 times the A piece, 34, times the B piece, 18, times this cosine of the unknown angle. Now, if we do this squared, 21 squared is 441. 34 squared is 1,156. 18 squared is 324. Minus, we got to do 2 times 34 times 18, 1,124 times the cosine of theta. So that's what we have there. Now, here's where students make a mistake. They go, oh, let's do this plus this, subtract that. You can't do that because look, this has 1,124 times an unknown. It's like times an x. If that were an x there, which is literally what you have there, an unknown, you wouldn't dare try to combine it with these numbers. These numbers can combine, but that 1,124 cannot combine with these numbers because it has an x attached to it. It has a variable attached to it, an unknown. So you can't mess with that piece. We can put these together. So we have 441. We add these guys together, it's 1,480 minus 1124 times cosine of theta. Now, people again want to put these together, but that's like 1,124x. It cannot combine with this. So we need to move this guy over. So we subtract 1480 from both sides. That goes away. On this side I have negative 1124 times the cosine of theta. On this side I get negative 1,039. Okay. Again, that we're doing a negative here, so you sort of have to flip them. Don't pay attention to that. Don't worry about it. Now, how do I get this by itself? Where this were an x, if this were an unknown, if I said negative 1,124 times some unknown equal that, you say, oh, divide by that. Well, that's what we're going to do. Simply going to divide by negative 1124 on both sides. Excuse me. Now, that goes away. Cosine of theta. When we do this division, I did it earlier. 8856 something, I don't know. Now, how do we get theta by itself? It says the cosine of some angle is this 0.848856. So how do I get this? Well, you know the way we get theta by itself, we got to get rid of the word cosine. The way you get rid of the cosine is you take the inverse cosine. That crosses it out. But if I take the inverse cosine there, I've got to do it there. When I do that, I get theta by itself. It's going to be approximately, I came out, excuse me, when I did it, 31.91. So let's just say that angle's about 32 degrees is what we have here. So when you take the inverse cosine of that, you're going to get 31.9 something. So I just rounded it up to 32 degrees on the answer sheet. There's how we have theta. You got to be very careful that you don't try to put those three pieces together. That's a common mistake that is made amongst most students. There you have problem 3. Good luck with the rest of them.